This lesson is on the distributive property. We're going to start with this little foldable. Everything just gets folded in and you cut on the solid lines. So we're going to start with what is that distributive property. The distributive property is used to rewrite expressions in simpler forms. Okay, so essentially if we have, let's say, a box, a rectangular box, and if it's 8 and x plus 5, then I know I could have rewritten the bottom as x and 5. So if I were to find the area, I would be multiplying 8 times x plus 5. Okay, and so I would have to be distributing to that 8 to each of those if they were inside the parentheses. Okay. Let's look at an example of the distributive property with variables. I could have x times x, and I know that x times x is x squared. Or if I had a times a plus b, this a on the outside of the parentheses is being multiplied by everything on the inside. So a times a is a squared, plus a times b is ab. An example with subtraction. Okay, we could, let's do a 5b minus 4, and I'm going to multiply it by -7. Okay, that -7 is in parentheses and it's sitting next to this set of parentheses. It doesn't matter that this is in the back of my expression up here. It's still getting multiplied by everything. -7 times 5 is -35, and there's a b there, so -35b. And then -7 times -4 is positive 28. Okay. It also works if your number is on the front, so -4 times 2a minus 3. It's the same thing. That negative is still being distributed to all of those things, the -4. So I have -4 times 2 is -8, and there's an a with it. A negative times a negative is a positive, and 4 times 3 is 12. An example with addition. We can say 3 times x plus 8. We know that we're still distributing that 3, since it's on the outside of those parentheses. Distribute means to multiply. And we're going to simplify this expression. 3 times x is 3x, and 3 times 8 is 24. It works if that number was in the back as well. So if I had 2x plus 6, and the 3 was back here, or whatever number, I'm still taking whatever's on the outside of those parentheses and multiplying it by everything on the inside. So 3 times 2x is 6x, and 3 times 6 is 18. Okay? So that's going to go get glued at the top of the page. The next thing that we're going to look at is using the multiplication property of -1. Okay, and it sounds complicated, but you've seen this a bunch of times before. That's when we have the negative on the outside of the parentheses, and I have an expression on the inside of parentheses. So still, I'm using the distributive property, but the only number I'm distributing is an imaginary or invisible 1. Okay, just because I need to know. It's not just a minus this expression. There is an understood -1 there that I'm going to distribute. -1 times +2 is -2. Keep the y. -1 times -3 is +3. Keep the x. Okay. All right, so let's do a couple of got it's. Do negative a plus 5, negative times negative x plus 31, negative 4x minus 12, and 6m minus 9n. Okay? Pause the video so that you can do those, and then play when you're finished. So here I'm distributing that negative to the a and to the 5, so I have negative a minus 5. I have a negative times a negative, so that's a positive x, and a negative 31. It's a negative 4x and a positive 12. And it's a negative 6n plus 9n. Okay? All right, the next thing that we're going to look at is combining like terms. So this is something that we've seen for several years. We're going to do an example, let's say 8x squared plus 2x squared. When you're combining like terms, we need to have the same variable and the same exponent. Okay? So in this example, the variable is x, and x is squared. So any other like term has to have an x squared. Luckily for me, there's an x squared here and here, so I can just combine those coefficients. We have 10x squared. Okay? Sometimes we're not going to have exactly the same exponents, even though they're the same variable. So let's do 5x minus 3 minus 3x plus 6x squared plus 4y. Okay? So we have, if it were me, I would circle all of the like terms that are the same. So I have a positive 5x and negative 3x. Here's an x, but it's squared, can't use that. Okay, so I'm just going to leave that, and then I can underline it or do it in a different, put a box around another one, and a triangle. They're all different, okay? So the circles, 5x, negative 3x, so 2x. Okay, I have a positive 6x squared, and it's good practice to keep the exponents with higher, or excuse me, the variables with higher exponents at the front. So let's put that up front, 6x squared, and it's a positive 2x. I did that, and I did that. I have a positive 4y, can't be combined with anything, and I have a negative 3 that can just get tacked on to the end. All right, let's do one more. Let's say 7 y cubed z minus 6 y z cubed plus y cubed z. Okay? So I have to find out what has the same variable and the same exponent. This is y3z. This is yz3. Those are not the same. It doesn't matter that there's the exponents of 3. This 3 goes with y. This 3 goes with z. So it can't work. But this is also a y3z. So that's a like term with this. Okay? So then I have 7 here and 1 here. So I have 8 y cubed z. And then the only thing left I just need to bring over is a negative, don't forget the sign, 6y z cubed. And then you're going to do a got it. Let's do 3y minus y and negative 7 mn to the 4th minus 5 mn to the 4th. Okay, pause the video and try those, and unpause it when you're done. You should have seen both our y's. A 3, this is like an invisible 1 in front of it, so this is 2y. Okay, and then here, my variables, mn4, so we're good. So I have negative 7 and negative 5. Negative 7 minus 5 more is negative 12. We keep the variables and the exponents the same. And that is the lesson on the distributive property.